Hello guys, this is the Smart Orbiter 3.0 I just received from LDO and I would like to show you how to assemble it. Let's see what's in the package. Okay, we can open it like this. So what we have here, we have the Smart Orbiter 3 and we have a box here with all kind of goodies. Yeah, so this is how your orbiter comes. It has the gears assembled, the connector for the motor, this is the 3-wire fan connector, and yeah, basically that's it. Let's see what's in the box. First, we have the Hotend. As you can see, no nozzle is mounted with the connector, the heat break. We have a thermal paste. This is very important. We have the Bondtech nozzle. This is 0.4 mm GHT. You can see there's 3 holes there. We have a nice screwdriver, cool, and 2 sets of screws to lock the Hotend in place, and a bunch of wires. These are extension wires for the motor, for the fan, in case you don't have a toolboard and you want everything to be connected to your main board. This is the cable from the electronics. You can see here is the small connector which should go inside here, the bottom of the orbiter. Yes, and on the other side we have a bunch of this kind of connectors, so it would fit with all kind of main boards, and you can search each pins or connection where to plug it in. Yeah, good. Then we have this same kind of connector, but a very short one. This is intended to connect the orbiter to the toolboard. I will show you this later. We have an extension cable for the fan. This has a 2 mm pitch pin on one side, which fits to the fan connector, and standard GHT pin connector on the other side. This is again an extension if you don't use our toolboard. And for sure we have an extension cable for the stepper motor, and this is for the Hotend. Yeah, we have here the connector to the Hotend, and then this is the thermistor connector with GST pins and 2 pins like this for heater connection. Great. Before we start assembling the Hotend, let me show you how to open the latch. Here's the screw. You can unscrew this retainer screw, get it out, and then the latch, the secondary gear with the tension arm, is you can remove it. Here you can see inside the orbiter gears. You should check if the gears are really aligned correctly, and this is also the way how you open the Smart Orbiter 3 in case some filament jammed inside or some debris, and you can clean it up. And when it's important things which I forgot to mention is this tension knob should be on open position, otherwise it applies pressure to the tension arm and it's really hard to remove. So this is in open position. Push it back, place back the screw. And good to go. Good. Before we start to assemble, we have to add thermal paste everywhere. Yeah. This is to ensure that the hot end has the highest possible flow and doesn't clog. First, you have to remove this silicone sleeve, yeah, and then you have to unscrew the heat brake. Yeah, apply some thermal paste on the heat brake. Screw. Open the paste. It's a bit messy stuff, but it's not that hard to do. Okay, it's a bit too much, but it's good enough. Good. Now let's screw this in. Here is the retainer, and you have to make sure that the retainer is fit into place correctly. There is a cutout of the in the hot end for that, and should fit there nicely. Okay, like that. You can use a small wrench to tighten the heat brake. It should be okay. Now take the nozzle. Same, apply some thermal paste. Doesn't have to be much, but this thermal paste helps. This thermal paste helps the heat transfer between the heater and the nozzle, so this makes sure that the nozzle has the same temperature as the heater. Remember, the sensor, temperature sensor, is in the heater core, not in the nozzle. So we want to have a good thermal contact between them. I put a bit too much paste here, but anyway, it's not so big deal. We can wipe it down using some paper towel. I think it's good enough. Now what we want in the next step is to tighten a little bit the nozzle. Use the same wrench as before and tighten it. Okay, that's good enough. Now we can install back the silicone sleeve, just like that. And it's time to apply some thermal paste on this bimetal part, this copper area. Doesn't have to be much, but this is again important to have a good thermal contact between the heat brake and the heat sink, so our heat sink is as effective as it can be, and we avoid clogs of the hot end. Maybe it's a bit too much again. Today I don't have a good pace control. I'm not used to do this on the camera. Okay, should be good enough. So now take the small screwdriver you received from LDO. Here is a small screw. This is the one which keeps the hot end in place. Unscrew a little bit to have the heat hot end inserted easily, and then it's a bit hard to find the hole, but should be possible. It's a bit tricky, maybe. Maybe by the first time. Yeah, and as you can see, you can rotate the wires in the direction you want. This was the main reason why I did not choose as a heat break for the heat breaker a screw, because if you would screw in the heat break into the heat block, then the wires would be defined where it comes. Yeah? And like this you can orient the wires in the directions you want. You might not want maybe this time to tighten the screw because you want to adjust it afterwards. But anyway, even if you tighten the screw from here, then the hot end will be locked in place, will not come out anymore. You can still unscrew this, unlock it any time and adjust it. A bit more, and then it should turn again. Great. Now with that, the Smart Orbiter 3 assembly is completed. You can either install it on your printer like this, or you can install it with our toolboard. Now I will show you how to mount the toolboard and connect it to the Smart Orbiter 3. What you will get with the toolboard is first toolboard, a small USB adapter. We already have the small cable which connects the inside electronics of the Smart Orbiter 3 to the toolboard. Then we will have our custom built USB cable. On one end we have this connector, and the other end this connector. This one will go inside the toolboard, and this one will be connected to our USB adapter board. USB-C cable and the holder components. There is this big part which helps to keep the toolboard in place and isolate the side part that is not touchable and you cannot see inside, and lock for the wire. I will show it a bit later. First, what we have to do is to use two 15mm spacers like this and screw them on the Smart Orbiter 3 backside. Here at the motor screws. That's one. That's two. I will tighten them just a little bit. Okay. This is the toolboard for the Smart Orbiter 3. We will have two other toolboards for the Orbiter 2 version, and on one side we have the connectors. Here is the special cable which is USB data plus minus, ground and 24 volt. Here we have the connectors to the Smart Orbiter integrated electronics. This small connector here is the connection for the 3-wire fan, for the Hotend fan. This one is for the part cooling fan. This is an X-stop connector, and here we connect the Hotend plus the thermistor. Here is a space for a jumper. With this jumper we select PT1000, so if you close this connection, the electronics is set up for PT1000 sensor. Then we have the connection for the stepper, which is this one, and this is for connecting a bed level sensor. Basically it has two digital ports. One is intended to be output, the second one is intended to be input, and the 5 volt and the ground. And here is how the back side looks like. We have several switch mode power supplies to supply the 5 volt on the board. This 3-pin fan controller, it's a special driver on this board because you cannot supply with a PWM a 3-wire fan, because the PWM signal will disturb the fan speed signal and the speed signal will be ruined. Yeah, here I use a special driver which is actually supplying the fan with a DC voltage, and therefore the speed signal is very accurate. Then we have our standard PWM pin. This is short circuit protected and can go up to 1 amp. Hotend connector. Here the output for the heater is short circuit protected. In case there is some issue with the wiring or a short circuit inside the heater, this circuit is self-protected. It will not be destroyed. You can even do some nice sparks, but nothing will happen. In the same way, there's a protection in case there is a short between the heater negative terminal and the thermistor negative terminal. This will end up in a thermal runaway in a normal system because nothing can stop the current from flowing into the hot-end heater. In this circuit there is a protection against this. If this short between the negative terminal of the heater and the negative terminal of the thermistor happens, the circuit will limit the current and will shut off automatically. So lots of protection features, even protection for reverse connection. If by mistake you connect the supply voltage in reverse, nothing will be happening. The USB connectors, again, they are automotive USB. Now many of you were asking me what is automotive USB. And basically in automotive we have to protect all the electronics from every kind of hazards, meaning short to bad, short to ground conditions. This input, this USB input is protected against short to 24 volt. Yeah? One of the main failure you can have, that one of the data lines make a short circuit to the 24 volt. This circuit is protected against this. If this happens, nothing will happen. For sure the communication will stop, but the circuit will not be destroyed. Okay, this is the toolboard. And then, as I mentioned about USB protection, the Raspberry Pi doesn't have a automotive USB, and in case you make a short of the data line to 24 volt, your Raspberry Pi most likely will die. And then here comes in place this small adapter board. The idea with this small adapter board is to have a connection, the supply via this connector with 24 volt, the tool head. This is the connection to the tool head with the USB ground and 24 volt. We have a small fuse and the USB-C connector, and has some electronics to protect the Raspberry Pi in case we have a short circuit. So even if you have a short bit on the wiring harness between the data lines and 24 volt, the Raspberry Pi as well as the toolboard is protected. Nothing will be destroyed. In the same way, you have to know if the ground, for example, is disconnected first on a hot plug, the circuit starts to be floating to 24 volt, and this in normal electronics will lead to an overvoltage situation. For these two circuits, this is not the case. They are protected against ground disconnection, meaning the ground wire in this cable, if it's broken, the electronics will not be damaged at all. Okay, now get back how we mount this on our orbiter. First you have to insert the electronics into this small adapter unit. This acts also as a spacer to make a space between the stepper motor and the electronics. And this should be mounted on the back side of the smart orbiter like this. We will need 2 M screws and 3 screws also. And it should be going on like this. The first screw, and this is the second one. You should tighten them, but not too much. Consider that this is a PCB and you can crack it, so be careful with that. No need to over tighten it. It will not fall off. So it looks like this. You can see that's nicely electronics on the side. It's very nicely covered. There is a gap here in the top near the connector and here in the bottom, and the idea is to have let the hot air to get out from in between, from the PCB, from between the PCB and the motor backside. Okay, now as I installed this, it's time to plug in the electronics. So first you can plug in the fan connector, and it should go like this. As I mentioned, here we can turn in a convenient direction the Hotend cables, and it's helpful to turn it 90 degrees around that we have more space to insert this small cable here. It's a bit not easy to get this cable in. You might need to use a flat screwdriver. Okay, and make sure that it's pressed in well. If it not goes easily in, it will also not come easily out. Yeah, will not come loose. Then insert the stepper connector. Now as the integrated electronic cable is connected, you can turn this back if you want, and you can tighten the hot end using the screw here in the front to lock it in place. It will not come out anymore. And you can connect a Hotend connector, and over this top side the integrated electronics connector. Again, flat screwdriver helps to press it in. Good. Now I have this installed. Next, this cable would go in like this. Great, and I have a strain release part for this mounting, and this is the lock part which you insert over the cable and just press it like down like this. Okay, and it's perfectly secured. Next, a small USB adapter board, and this connector we plug in the Toolboard. Here we have the USB-C connector with the USB-A on the other side, and I have here a power connector. This is a prototype made by myself, which should go in like this. Yeah, this part is the positive and this one is the negative. Post 24, here is 0, E and D. But as I mentioned, even if you make a mistake and you connect it reverse, nothing will happen. All these cables will be supplied with the toolboard. And then of course the USB connector should be plugged in into the Raspberry Pi USB port, one of the ports of the Raspberry Pi, like this, and that's it. I hope you liked this video. Now you know how to assemble the Smart Orbiter 3. Please don't forget to use thermal paste everywhere inside the Hotend when you install the nozzle and the heat break. It's very important. We want that the heater have a good thermal transfer into the nozzle and the heat break cold end is cooled as good as possible by the heatsink. Have a great day.